In this video, I'll explore a bit more about Python by organizing my current project into functions and modules to make it easier to maintain. Python projects are usually made up of files called modules. Each file contains functions and data used by the project. My project currently consists of one file, and the data used to build the XML output file that's generated by this program is hard-coded into the program. I'm going to divide this project into two files. One file is usermapper.py right here. It will contain the program logic that writes the XML file. The other file is going to be mapperdata.py, and it will contain the data used to build the file. Currently, it will still be hard-coded data. To do this, I will just copy the data generation text from usermapper.py and put it in mapperdata.py. And I'll also copy the hashbang to the top of this file. There, now I have two files or two modules for this program. Now in the main program, because some of the logic is now in another module, I need to import that module into the main program. So I am going to import mapperdata. Now that doesn't work really great because then I would have to go down here and change all of the variables that I already have in this program and change them so that they incorporate the module name. For example, students would have to become mapperdata.students. So of course there's another way to import. I can import particular functions or data sets from a module. So I can say from mapperdata import students, IP. Those are the two data structures, students being the top level data structure for all of the students, and IP being the variable data structure that I may change IP addresses on from time to time. And so I broke that out separately, and I have to import them both to make this program work. And that should be good enough. Let's actually see if this new structure works. I'll open up a terminal and run the program. So I'm running usermapper.py, which is the main program which imports the other module, mapperdata.py. Everything ran, so then I should see that the usermapping.xml file has been created properly. And it's been created. So the program still works after I split it into two modules. Another feature of modules I want to experiment with is the if name equals main logic. Typically in a module someone else writes, and even one that you write, you'll often see at the end of the module, and this is something I've noticed, that many of them end with this text. If _name is equivalent to, in quotes, _main, quotes, comma, do something. And in this case, because this is a module and it's generating all of the data structures I want to use, I'll just have it print the data structures that it creates. So I'll just have it print students, separate line, I'll call that good enough. Now, what this does for anyone who's writing these modules is it lets you test the module all by itself. I don't have to run usermapper.py in order to run the logic in mapperdata.py. If I didn't have this logic in mapperdata.py here at the bottom, when I ran it, I would see no result. It would just create the data in memory, and then when the program ended, it would delete all of that data that was in memory, and nothing would happen. But now, because this logic is here, what happens is it tests if the name of whatever's running is _main_. In other words, if this is actually the file that is actually being called to run, if this is the main file, then do the following statements. So when you import this file into another program, anything in this if name equals main will not run, because when you import it into another program, it's not the main module. But when you run it all by itself, it is the main module. This checks for that and then runs this logic. And this is a great place to put test logic inside a module and lets you test the modules as you work on them. So let's try this out. I'm going to run the mapperdata.py module. Oh, I actually forgot to save this file. There, now that it's saved, that change should take effect, and boom. Now this is going to print out the list that contains 2 student dictionaries. There's one student right to there, and there's the other student. And the IP dictionary is the IP addresses for all the devices that will get loaded up into this dictionary by the main program. That allows us to test our mapperdata.py module. And to double check this, we'll run the usermapper.py program. This is going to print out the dictionary as it gets loaded with all of the IP addresses. And if we go up to the top here, we can see that it did not run this logic here that was built into the module. And now that we've got a working program, we don't need those debugging print statements anymore. So I'm going to get rid of those. And I'm going to look for things that I can turn into a function. So this is all data. This is essentially the data module. So that makes sense. And over here, I see some operations that maybe I should turn into a function. This item up here populates the student's dictionary with the IP addresses that are stored in the IP dictionary. I think that could be defined all by itself as a function. And then underneath the function, you have to indent everything. And then this function here, or this set of code here that's related to opening a file and writing XML to the file, I think that stands alone and could be a function as well. And all of this can be indented. And many text editors have an automatic indenting function just with the tab key. There, everything's indented. Now to run this program, I need to actually run these 2 functions. And to do that, I'm going to do the same thing I did over in the other module. I'm going to put in that if name equals main logic. And the reason I'm going to do that is that this program here, even though it's the main program, could potentially be used by other programs in the future. And I might want to import this into another program. This just makes the code more reusable. And this is why when you look at Python programs, you'll often see this. You'll see a bunch of functions defined or import statements. And then you'll see this if name equals main, and then really the main parts of the program below that. So the 2 functions are user loader and XML writer. And here I'm treating Python as a procedural programming language. I'm not even passing parameters to the functions. I'm just telling it to run one set of code and then the other set of code. And then we will see how that works. There, and it wrote that file. And it's getting written by these 2 functions, user loader and XML writer, and they run only when you run usermapper.py as the main program. Now let's continue to organize this code. I see some opportunities to simplify this big chunk of code here. Every single one of these for loops could be part of a function, and then this main function would just call each of those smaller functions. And what this would let us do is if we change the way the parameters part of this puzzle works in the future, we just know to go to that one place in the code and change the parameters function. So I'm going to start simplifying this from the inside out. I'm going to create a write parameters function. And that automatic indenting there pushed that in, so I have to pull that out. in this function, I need to pass in some parameters, and I need to return some parameters because I'm working with other functions that are all sharing the same dictionary. So I need to receive into this function the actual dictionary I'm working with, which I think is the parameters dictionary, the file name I'm working with, and then the indent, because the indent is getting passed around through all of these as well. So I'm going to pass in the user mapping object into the name file name in this function. So I need to change it to file name in the function. And I should return the indent at the end of the function. I don't think I need to return anything else. Now down here, where I cut all of that text out to create the function above, I need to call the function I created. And I need to pass in the parameters. The file name is called user mapping, or the file object, I should say. The dictionary is, I don't need to use this anymore. I'll just pass straight in the call for the actual, where I actually pull that dictionary out of the dictionary it's nested in. And the indent is just the indent. And I think the way that Python handles global variables and local variables will allow this. The indent gets passed in. The indent variable name inside the function is unique to that function. And then when it returns indent, it modifies the global variable again. I'm just going to make this a bit wider so we can see the structure of the code a little bit better. You can see now I've got the write params function up here, and down here I call it, and it's inside this for loop. So I'm hopeful that everything is going to work. Let's try this. So an indentation error, that will have something to do with the way I've written this. Well, it might be because it doesn't understand this is a function because I misspelled the function name. I had to take a break and figure this out. And now I understand it's because I'm using both tabs and spaces in this file to create the indents. When I used the automatic indenting function to move some of this code around inside the file, I was actually sticking in tabs. And that's because the editor here is programmed to use tabs. So I should click on the Use Spaces button. And now it's going to insert 4 spaces for an indent instead of a tab that is 4 spaces deep. And now I need to go back and get rid of all the tabs. So there's a tab, delete. And I wonder if I hit tab again, do I get spaces? Yes, I do. So I'm going to go and fix all of these and then run the code again and see what happens. So Python is particular about the white space. We need to be aware of that when we're writing Python programs. And when you see an indent error like that, and you don't see any obvious errors in your code, it could be something tricky like that. I'm just using a basic text editor here that comes with the operating system. This is not a programmer's text editor, which is another reason I ran into this problem. Programmer text editors tend to be a little bit smarter, or at least they're more complicated, so you spend more time setting them up at the beginning and you make less assumptions about how they work. Either way, watch out for spaces and tabs. Now let's run this again and see what happens. It seemed to run okay. Let's have a look at the file. It looks like the file printed out properly. Let's go back and do some more cleanup. So everything here in this section could also be its own function. Everything between the 2 authorized tags. So I'll cut that out and I'll put that up here. Now this function should bring in the file name, a dictionary, one of the nested dictionaries. This time it's going to be the dictionary that contains all of the devices with a unique copy of the parameters dictionary nested under each device. And of course the indent, because we're passing that indent around between different parts of the program. And because I have just reused the lab dictionary name here in the function, I don't need to change anything else in the function. I think I'll just bring all this text together to make it clear everything's part of the same function. And then I'll just call that function here. And I need to fill that in with the right values. The file object is user mapping. The lab dictionary comes from the student dictionary with the devices key. So every device has its own dictionary. And of course the indent gets passed around. I don't need the extra line there anymore. You can see this XML writer function is getting smaller and simpler looking, maybe easier to understand now. I'll save that and let's see if I made any big mistakes. I forgot my colon. I have to have a colon after every definition statement. It says the user mapping name is not defined. I see the problem. I'm using the user mapping name before it's defined, and it's defined down below when I open up the usermapping.xml file. So it's not defined yet when Python actually looks at this function. And also, I've done that wrong. I need to change the user mapping name in this function to file name, because file name is the name of the variable that gets passed into this function, and it's the user mapping object that gets passed into the file name parameter, which becomes the file name variable in the function. There, that worked. And again, the file looks good. And I think there's one more part we can clean up. We can take this block of code and we can turn it into a function. And I don't think I need to pass in any dictionaries. Yes, I do. I have to pass in the student dictionary still. The students directory is a global variable, and I don't want to create confusion in this function, so I'm going to just give a slightly different name, students directory, and then that's clear that this is a variable that's inside this function. And everywhere I see the students directory, I just change that as well. And then down here, we just call write student. All right, let's see if we broke anything. I'm always forgetting these colons after the function definition, but that's okay. Python catches these errors quite quickly. Up here, I forgot to change the word user mapping to file name. Everything's working. As I think about this, I'm not really sure that I've made this any clearer. It kind of hides things, right? XML writer looks like it does one thing, and then you have to go back and look at write student. What's write student doing? Oh, it's calling write dev. What's write dev doing? And so on. It's not clear that you've got like this nested structure. Any point, that was a good practice in dividing a program up into functions and in using the if name is equivalent to main statement to run the code at the bottom of the program when you run this file as the main program. To clean up just a few leftover things, I remember that at the top of the file I had intended to make the user loader function a little bit easier to read. So instead of these little single character iterables, I'm going to say for student in students, for device in student devices, student devices, and then the device and IP device. Okay, that makes that look a little bit nicer. And then I'm thinking I should treat this as a more self-contained function. So I should actually pass these parameters into this function and not just use it like a procedure that uses all the global variables. This, I think, is a safer way to program. And so since I've changed students to students directory and IP to IP directory in this function, I'm going to make those changes. And that means down at the bottom when I call this, I need to bring in students and IP into the function, into the user loader function. And I'd like to do something similar with XML Writer, make it stand alone. So what global variables is XML Writer using? It's using the students global variable, and that's it. So what I should do here is I should have it bring in the students directory and make sure that that's named appropriately everywhere in here. And then here, same thing. Let's see if I broke anything by creating that kind of fix. Okay, that looks good. And that's a little bit more descriptive now. I know I'm going to do a user loader with students and IP, and I'm then going to write students. And all of the functions are more independent and don't rely on global variables. Now, looking at everything again, I think that the students directory is still being passed around as a global variable. The user loader program is modifying the students directory that gets imported into this program, and it's not returning it or anything, it's just modifying it in place, and then XML Writer is coming along and using it. Based on what I've been reading, it would be better that user loader returned the students directory so that you get inputs and outputs from that function. So the way to make a function return an object is to use the return statement. The user loader function brings in the students directory and the IP directory as inputs, modifies them, and then returns the students directory as an object. The way this would impact the program is that user loader students IP returns something. I mean, it also changes the students directory in place, and this code will still work as is. But the better way to do things would be to assign a variable to the object that's returned by user loader students IP. Right now, I'll just call it structure. This is really the modified structure is really a pointer to the object that is the modified students directory. XML Writer uses that object as its input. Let's see how this works. So the output is the same. And I think that this main program is a little bit clearer now. I am taking the output of user loader and I am bringing it into XML Writer. I'll just tidy up this file a little bit and save it. Now to use this file, let's say I'm building a lab that's different from the one that's already defined, then I need to modify the mapperdata.py file. And in the future, I'll probably try to create a different format for inputting the data, some sort of easier to read format. Let's say, for example, I need more parameters. According to the Guacamole documentation, there are a lot more parameters that I could use. I can set the color scheme, and I can enable SFTP for file transfers and set the SFTP root directory. So that's what I'm going to do. I'm going to set a color scheme parameter. An enable SFTP parameter. And an SFTP root directory parameter. In addition to that, I think I'll have one more server in the lab. And because I did that, I need a 5th copy of the parameters directory. And let's say that I want to add another student, maybe 2 more students. Again, I'm going to need 2 more student device directories. And then down here, I'll just copy these and modify them to create 2 more student dictionaries. And I'll break the rules. I won't bother changing their passwords. Oh, actually, I should change their passwords just to make sure things are happening correctly. And make sure I set the devices dictionary for each student. And then I need to add them to the list. And server 3 needs its own IP address. And let's imagine that this lab, all the nodes are on a new subnet. So if I save that and then run this, you can see now I've got, for example, a new node, server 3. There's new parameters for everything. I should also see up here that I have a student 04, student 03, and everybody's got the same equipment. So I've created a reasonably flexible program where I can modify the mapperdata.py file where all the dictionaries are defined, and then the usermapper.py file will turn that into an XML file. And where I get my efficiencies here is because it's repeating the same set of equipment for every student and putting in the same information for each set of equipment. And if I need to change one thing like IP addresses, I don't need to go through a big file and find them everywhere and change it. There's a lot I could do to make this more flexible. I think I'm going to take a break from that now. And in my next video, I'm going to cover how we use version control like Git and GitHub and a more professional text editor like VS Code. And those 3 things make it easier to maintain this program and make more changes to this program as we work along. Thanks for listening.